Down there, life continues. The traffic is awful. Stocks go on trading. Down there, life continues. The traffic is awful, stocks go on trading, and Star Trek is still showing.
Good day, grade 8 learners. Welcome to today's natural sciences lesson. My name is Pathuchezo Singo, and this lesson is proudly brought to you by the Gauteng Department of Education. In today's lesson, we are going to be learning under the knowledge area energy and change. The topic is energy transfer in electrical systems, and the subtopic is components of a circuit and effects of an electric current. Now let's go through the lesson objectives to see the goals that we need to achieve by the end of today's lesson. So at the end of the lesson, you should be able to identify the components of an electric circuit, state the functions of components of an electric circuit, draw circuit diagrams of a simple circuit, explain the effects of an electric current. Oh, this is sourced from your CAPS document on page 47 to page 48. Now let's go through pre-knowledge. So this is what we have learned prior to today's lesson. In grade 5 and grade 6, we were introduced to circuits and current electricity. And in the 6th grade, we also got introduced to energy and change. So we are adding on to the knowledge that we gained in grade 5 and in grade 6. Now let's do the baseline assessment. Number 1. Draw a table in which you classify the following as a conductor or insulator. Plastic, metal paper clip, a piece of cardboard, a coin, a piece of wire, and rubber. Number 2, draw a simple circuit with 2 cells, 1 light bulb, conducting wires, and an open switch. Take 4 minutes to quickly draw the table and then draw the electric circuit. See you after 4 minutes.
What does that mean? An attitude of gratitude is the quality of being thankful. It's the quality of giving thanks. Ukubonga, kulebuha. It's to be grateful. You and I have so much to be grateful for. You and I have parents who make sacrifices day and night for us to be at school. You and I have people who believe in us when we don't believe in ourselves, who love us when we don't love ourselves, who invest in us day and time again. Whether it's a teacher, it's a principal, it's a driver, it's a guardian, we have so much to be grateful for. And so I challenge you, young person, be thankful, ubonge, lebuha, be grateful each and every single day of your life. Strive to display an attitude of gratitude.
Welcome back, learners. Now let's answer the questions together. Now, the first question read, draw a table in which you classify the following as a conductor or insulator: plastic, metal paper clip, a piece of cardboard, a coin, a piece of wire, and rubber. Draw a table. So here is the table. So the table has two columns. On the left, we've got conductor, and on the right, we've got insulator. So under conductor, that's when we entered all the materials that can conduct electricity, or metals that are classified as conductors. The first one is the metal paper clip, a coin, and a piece of wire. And then insulators. The insulators, we've got a plastic. So these ones do not allow an electric current to flow through them. They're the plastic, the piece of cardboard, and rubber. Take 1 minute to quickly copy down this table, and then after 1 minute, we'll move on to question 2. Welcome back. Now let's answer question 2. You are required to draw a simple circuit, electric circuit rather, with 2 cells, 1 light bulb, conducting wires, and an open switch. There is our circuit. So we have a light bulb, an open switch, so there should be a gap. There should be a gap there. And then 2 cells. Remember, 2 or more cells make a battery. How do we know that there are 2 cells? Because we've got this one represents 1 cell, and then this one also represents another cell. So take 1 minute to quickly draw this simple cell, and then we will move on to terminology afterwards. Welcome back. Now let's move on to terminology. Okay, the first term is electric circuit. Electric circuit, this is a path through electric charges can move. electrical current, the flow of electric charges in a closed circuit. Conducting wires, a material which electric charges can flow. Switch, a device that is used to control the flow of charge in a circuit. Let's look at the second slide. Cell, a chemical system that stores electrical potential energy. Battery, two or more cells forming a chemical system that stores electrical potential energy. Resistors, a device that opposes the flow of current. Filament, a very thin thread or wire. Okay, now let's learn about the components of an electrical circuit. So what are these pieces that make up an electrical circuit? For starters, we have conducting wires. Conducting wires, these are one of the basic components of an electric circuit. These are our conductors. So, what is their function, or how best can we describe what conducting wires are? Conducting wires are materials through which charges can flow. So, they are materials that allow charges to flow through them. So, these are our conducting wires. So, where do we get them from, or what kind of materials are they? Conducting wires are usually made of metals. Remember when we're learning about different materials? Metals are very good conductors of what? Of electricity. So we use them to make conducting wires, the conducting wires that we use in our electrical circuits. Now, conducting wires are capable of carrying electricity over short distances. So these are your cables that you use for your electrical appliances. The cable for your kettle is usually not long. It's probably 30 or 50 centimeters long. Or very long distances, such as from one house to another, or throughout an entire neighborhood, or throughout an entire city. As you can see here, we've got pylons there. They carry electricity through over long distances, and cables for appliances carry electricity over very short distances. All right. Okay, let's learn more about these components. Next, we've got switches. We did briefly talk about switches in our previous lesson. Now, let's learn more about switches because they are a very important component of an electrical circuit. So, switches are connected to a circuit. Why do we have them in circuits? We have them in circuits so that they can break the flow of an electric charge in a conducting wire. Remember, a conducting wire allows current to flow through it, or it allows charges to flow through them. So if we have a switch, then we are able to break that flow if need be. So when a switch is said to be open, the conducting wires are separated, meaning that there is a gap that has been created between the conducting wires, and that gap does not allow charges to flow. If we look at these two diagrams that I've just pulled up, the two illustrations. So when the switch is said to be off, it is open. You see there is a gap. So no current is flowing. If no charges are flowing, then our lamp is off. Our lamp is off. Our switch is off. Our switch is open. Then there is a gap, and then no charges are able to flow. Then our lamp is off. So when the switch is said to be closed, the conducting wires are able to allow the electric charges to flow throughout the entire circuit. Switches are very good because they provide a very convenient way of controlling electric circuits, because they can allow us to stop or start the electric current whenever you want. You can switch on the light bulb in your house when it is dark, and you can switch them off during the day when you can be able to use natural light to move around. So here in this diagram, you see our switch is set to be on, so which means switch is closed. Why are we saying switch is closed? Because the gap is closed. The gap between the two conducting wires created by the switch is closed. When the switch is closed, then we have charges. They are able to flow. Charges are able to flow. Then our lamp switches on. Our lamp switches on, switches on, switch is closed, circuit is complete, charges are flowing, then your lamp is on. Now, we have different kinds of switches. When you get home, there is a box, some call it a fuse box, some call it a switch box, but it is a box where you've got your main switch. Your main switch is very important. It is important. You see it in houses, in homes, you see it in buildings. They control how much electrical energy flows through the house. The amount of electrical charge flowing through a kitchen stove is very different from the one that flows through the lights or the plugs where you plug in your electrical appliances. This switchboard here is very important. The switchboard is very important. There we have our main switch there that controls how much electrical energy flows into the house. Then the other switches there, as you can see, there's more than one of them because there's more than one plug or there's more than one electrical outlet in the house. There's one for the kitchen, so the amount of electricity that flows to the plug for the kitchen is very different to the one that's going to flow to the plug where you're connecting a television set or an electrical kettle, or where you wish to charge your phone. So this is very important. Switches are also used in other electrical appliances, as I've mentioned. They are used in electric kettles, in computers, in cell phones, in torches. Whenever you need to switch something on, there is a switch. So there are different kinds of switches that we see out there. Some are labeled on or off. Some where this one looks like a knob for the stove, where you can either choose the amount of heat you want. Do you want it at 1 or at 2 or at 3? Also, we've got this type of switch that has only one button, or this one that requires you to move it forward or backward. So there are different kinds of switches. Even that switch that when you get into a car perhaps and you want to open the window, pressing it down is closing the switch, so it allows current to flow through the car, and thus you are able to open your car window. Another important component of an electrical circuit is the cell or the battery. The cell, remember, is a singular, and two or more cells make a battery. These are a source of electrical energy, so they are the source. So a cell, remember, we said, is a chemical system that stores electrical potential energy, and a circuit is not complete without a cell. We need to get the energy from somewhere, and the cell is usually the source. So the cell is connected to the bulb via the conducting wires, of course. The bulb lights up because of what? The chemical reactions that occur within the cell, and potential energy is then transferred to kinetic energy. Remember when we're learning about energy transfer in the previous lesson? So here we've got a battery, which is two or more cells in a combination, and then we've got the singular, the cell. We've got the singular cell. So what more can we learn about the cells? So the cells have what are called terminals. And how many are there? There are two terminals. We've got a positive terminal and we've got a negative terminal. So how do we know which is which? So usually with the cell or a battery, you will have these two symbols there. So the minus represents the negative terminal and the plus represents the positive terminal. So these are the two terminals that you find in the cell. And then in singular, in your dry cell, you find a knob or some kind of raised part at one end. Always know that that is the positive terminal, and the flat side, they always know that is the negative terminal, that is the flat side. More on cells. So how do cells move out of the how do electrons rather move out of the cell? So electrons move out of the cell via the negative terminal. So they move out of the cell via the negative terminal through the conducting wires, through the bulb, and they enter the cell through the positive terminals. So electrons are able to transfer energy from the cell to the bulb, allowing the bulb to light up or to switch on, giving off energy such as light and heat, giving energy off as light and heat. Now we know we've seen different types of cells. You've seen round ones, you've seen cylindrical shaped ones, you've seen that big car battery that is in the car. So cells come in different types and they also come in different sizes. Why? Because cells are used for different appliances and different appliances require different amounts of energy for them to work at their best, or for them to work to full capacity. So they come in different shapes and they come in different sizes. Another component that we find in an electrical circuit are resistors. What are they? These are materials that oppose or resist the flow of charge. Remember we said charge flows through conducting wires. So if there is a material or an appliance that resists that flow of charge, we call it a resistor. So they offer electrical resistance. They offer electrical resistance. So electrical resistance is a measure of how much an object opposes or resists the flow of charge in conducting wires. So conducting wires offer different amount of resistance. So they're different. Remember, metals, there's more than one metal that can conduct electricity or can allow for the flow of electricity. So conducting wires offer different amounts of electricity. So that copper wire, that is a favorite, does offer some resistance, but it is not as much. That is why copper wire is a preferred. It is preferred. So this is why they become hot when charges flow through them. When these metals have charges flowing through them, they become hot. It's because of the resistance that they have, or the resistance that they carry. A light bulb, or rather a torch bulb, has some resistance. There is a small wire that we call a filament. It is very, very thin. The filament wire is the one that resists the movement of electric charges. Remember we said charges flow from the cell through the conducting wires and to the bulb. So when they get to the bulb, they are going to reach a point where there is the filament. The filament, that wire, that type of wire, resists the flow of electric current. So while flowing through the filament or through the resisting wire of the filament, electric charges then, because of that opposition, because of that resistance, they pass off some of their energy to the particles of the filament, causing it to heat up. And as it is becoming hot, while hot, it gives off light. And while giving off light, it also gives off heat energy. So that's how a light bulb works. So here's a picture of a light bulb. So we've got the base, and then up here we've got the filament. So when the electric charges, they come in and they get to this point where they get to the filament, they're going to come across some resistance. So as they come across some resistance, they give some of their energy to the particles of the filament. So they pass off some of their energy to the particles of the filament, and they cause the filament to heat up. So when the filament heats up, it glows. And when it glows, it gives off light and heat energy. So that is how a light bulb works. So many household appliances, so it's not just the light bulb that is a resistor. Many other household appliances do offer some resistance, like electric heaters. Remember, resistors oppose the flow of current, and as current is trying to move in whatever direction it to be moving, it's going to give off heat. So this is where the plan for electric heaters comes through. And kettles to boil your water for your tea, geysers to warm water before you bath, and stoves to heat up and cook your food. So Resistors are able to heat up using electrical energy and provide a useful output such as heat energy. We need electrical heaters to warm us up. We need stoves to cook our food. We need kettles to boil water. So resistors are offer us an advantage in that particular way. Now, some resistors are specially designed to provide resistance in electrical appliances such as television sets and radios, so that the right amount of current is fed to the components to make them work properly, to make us have that light energy that you see on the television set, so that you're able to see those pictures for those favorite dramas, soaps, and TV shows that you like to watch. So here we've got an electric heater. As you can see, it's got 3 bars, and those bars are glowing. That glow means there is a lot of heat energy coming from those 3 bars. Then we've got an electrical kettle there that has a heating element inside of it. That element, when it gets hot, it also heats up the water that is inside the kettle until it boils. Now we've come to our first activity. So I need you to complete the table below. So we've got 2 columns, a component and a description. So where there's a gap, you fill it up. Like for example, we've got resistors. There's a component, you need to describe what a resistor is using 1 sentence. We've got a gap under there, under resistors, but we have a description. These are materials through which charges can flow. And then we've got a cell. What a cell, you need to describe what a cell is. Take 3 minutes to quickly fill in this table. Then after 3 minutes, we will do corrections together. Don't forget to send in your responses to our WhatsApp number 079 578 2908. Until then, let's see you after 3 minutes. Welcome back, learners. Let's answer these questions together. Complete the table below. So under component, I had resistors. These are materials that oppose or resist the flow of charge. Conducting wires, these are materials through which charges can flow. A cell is a source of electrical energy. Take 1 minute to copy down these corrections, then after 1 minute we will continue with our lesson. Welcome back, learners. Now let's move on with our lesson. We're still under components of an electrical circuit. So electric circuits are represented diagrammatically by circuit diagrams, and in those circuit diagrams we use symbols or circuit diagram symbols. So we're going to go through each component and each symbol. So a wire or conducting wire is represented by a solid line. So when you're drawing a circuit diagram, you use a solid line to represent your conducting wires. Resistors are shown by a solid line which has a zigzag in the middle. The light bulb is a circle that is crossed in the middle like that. The cell, you draw a solid line there, and then one vertical line, two vertical lines, one shorter than the other. So the vertical line represents the positive terminal. The long vertical line, or rather the longer vertical line, represents the positive terminal, and the shorter one represents the negative terminal. Then a battery, we all know, is two or more cells. So we've got, this is our first cell, and then this is our second cell. And then a switch, this is an open switch. For the switch, we have a gap. You must show the gap, so you draw your two dots here to show where the conducting wires end, and then you draw a diagonal line so that you show the gap, that it is an open switch. If it is a closed switch, there's going to be a line joining these two dots together. So these are the symbols for our components. Okay, now let's see, how do we draw a simple circuit? So this is a picture. This is a picture of a simple circuit showing us our cell, showing us our wire, our switch, and our light bulb. But this picture is not drawn in symbols, and we need to learn how to use the symbols to draw our simple circuit, of course. Now, this here is the illustration that shows our simple circuit drawn using our symbols. The symbol for a light bulb, the symbol for a switch, and the symbol for wires, and the symbol for the cell, with the plus and the minus showing which one is the positive terminal and which one is the negative terminal. So now we have a chance for you to draw. Let's see if you can draw your own simple circuit. So draw the circuit diagram below using symbols. I'll give you 3 minutes to draw your circuit diagram, this particular circuit diagram, but using symbols. Take 3 minutes to draw. Welcome back, learners. Now let's draw the circuit diagram. There we go. There is our circuit diagram. So we have our bulb represented by a circle with a cross in it. Then we have our cell represented by the two vertical lines I was talking about, one longer and the other one shorter. And then the plus sign representing the positive terminal, and then the negative sign representing the negative terminal. Then we've got our solid lines to represent our conducting wires. Okay, now take 2 minutes to quickly copy down the drawing. Then after 2 minutes, we will continue with our lesson. Welcome back, learners. Let's continue with our lesson. Now we're going to learn about the effects of an electric current. So what effect does it have? An electric current can do the following. It can generate heat in a resistor, as you have seen in electric kettles. It can generate a magnetic field, and it can cause a chemical reaction in a solution. It can cause a chemical reaction in a solution. So let's start off with the heating effect. So as the electrons are moving through a resistor, they are going to encounter some resistance. Remember, a resistor's core purpose is to oppose the flow of charge and offer some resistance. So the electrons will encounter resistance and they transfer some energy to the resistor itself. And for example, the element in a kettle. So some of this energy is transferred to the resistor as heat energy. And in an electric kettle, it has a heating element. So this is our resistor, and this resistor, after getting some energy, after getting heat energy, it becomes hot. Then it transfers that heat to the water that is in the electric kettle. Then that water is going to heat up until it gets to a point where it boils and the kettle switches off. Next, we have the magnetic effect. The magnetic effect. So when an electric current passes through a wire, that wire starts behaving like a magnet, and then it creates a magnetic field around it. And it creates a magnetic field around it. So this is the second effect that an electric current has. And then next, it has a chemical effect. It has a chemical effect. An electric current is capable or is able to cause or can cause a chemical reaction. And this reaction has a special name. That reaction is called electrolysis. Okay. Now, right. So let's start activity 3. Let's start activity 3. Number 1, when an electric current is passed through certain liquids, there will be a chemical change. This process is called blank. Fill in the blank. Number 2, in heating appliances, the heating element is made of materials with blank. Number 3, what effects does an electric current have? Take 4 minutes to answer these questions. Then after 4 minutes, we will do the corrections together. Welcome back, learners. Now let's answer the 3 questions. When an electric current is passed through certain liquids, there'll be a chemical change, and this process is called electrolysis. So this is when these are one of the effects of an electric current. Remember, in term 2 we did learn about electrolysis. We did learn about electrolysis in the decomposition of compounds. So this is where we can have a nice use for an electric current. And then in heating appliances, the heating element is made of materials with high melting point. So the material that you use, if you want to choose a material as a conductor, if you want to choose a material as a resistor, it has to have certain specifications, or it has to have certain physical properties. And in heating appliances, the material needs to have high melting points. It has to have a melting point that is quite high so that it doesn't melt. Imagine if the element in your kettle just melted after reaching a particular temperature. And then what effects does an electric current have? What effects does an electric current have? It has chemical effects for the process of electrolysis. It has heating effects. These heating effects are taken advantage of in certain heating appliances, your heaters, your geysers, and your electric kettles. And it has magnetic effect. This is when an electric current, when it is passing or flowing through a conductor, it tends to create a magnetic field around it. It tends to create a magnetic field around it. Now, take 2 minutes to quickly copy down these corrections. Then after 2 minutes, we will wrap up our lesson. Welcome back, learners. Now let's wrap up our lesson. What did we learn today? Today we learned about components or parts of the circuit. These are the parts that make up a circuit. You've got the cell. What does the cell do? The cell gives energy to the circuit, so it provides energy. And this is the symbol for a cell. So we've got the longer line and the shorter line. The longer line represents the positive terminal and the shorter line represents the negative terminal. Remember, 2 or more cells makes a battery. 2 or more cells makes a battery. And then we learned about the wires, the conducting wires that are usually made up of a material called copper. The conductor wires or conducting wires allows electricity to flow through them. So they allow electrical charges to flow through them, which is very important in the circuit. Then we learned that another component of a circuit is the light bulb. This is the symbol. It's a circle that is crossed in the middle. What does the light bulb do? What is its function? It uses the energy. Where do we get the energy? We get the energy from the cell. It uses the electrical energy to give out light energy, lighting up different spaces that we occupy. And then we have the switch. The switch makes a gap in the circuit to turn it on and off. So it regulates our flow of current. If you don't want current to flow, you simply open the switch or switch the switch off. If you want current to flow within a circuit, you switch it on or you close the switch, completing the circuit. And to represent an open switch, we use this. So you've got your two dots there, and then you've got a diagonal line coming from one of the dots. To close the switch, you just simply draw a line connecting the two dots together. That will be your closed switch, the one that allows current to flow through them. To create a gap, just draw the other one. So these are the components of our circuit. And then we learned something else. We learned about the effect of an electric current. An electric current can do the following. It can generate heat in a resistor, it can generate a magnetic field, and it can cause a chemical a reaction in a solution. It can cause that. This is our process of electrolysis, where we have electricity flowing through a solution and thereby causing a chemical reaction within that solution. Then here this picture represents a magnetic field that is caused by the flow of current. If you follow this here, so this is our conductor, and around the conductor we have the magnetic field. Forming, and then the heat. An electric current is capable of generating heat in a resistor. We use resistors in different electrical current appliances, and one of them is the electric kettle that we use to heat up water or to boil water. So this is one of the effects of an electric current. This is an effect. Okay, don't forget to send in any questions you may have or answers to any of the questions that were asked in today's lesson to our WhatsApp number 079-578-2908. Now let's move on to the homework slide. Take 3 minutes to copy down this table and the information that is in the table. That is your homework for the coming week. Welcome back. I'm sure you had enough time to copy down each of the information on the homework slide. All right, grade 8 learners, thank you so much for joining me in today's lesson. I hope to see you in the next one. Until then, bye bye.